Welcome to JDesigner Tutorial 5, Oscillators and Sliders. Circadian rhythms are common occurrences in biological systems, and many of these rhythms are controlled by biochemical oscillators. In this tutorial, we will investigate a well-known oscillator called the Oscillator. This oscillator is a highly simplified model of the famous Belousov-Zhabotinsky chemical oscillator. The reaction scheme is shown on the screen. One of the characteristic features of the scheme is the autocatalytic nature of the second reaction. That is, for every 2x species consumed, 3x species are produced. This reaction is therefore quite unstable. However, as x increases exponentially, it also removes y exponentially, the result being that at a critical point, the second reaction stops due to lack of y, and the concentration of x collapses. Y now starts to build again due to the third reaction, and in turn will eventually stimulate the autocatalytic reaction. This process of crash and boom continues indefinitely, or until the source material A and B are used up in a real experiment. In this tutorial, we are going to use the interactive slider capability to study the effect of the different rate constants on the oscillatory properties of this reaction network. This model introduces a new concept, non-unity stoichiometry, which we need to deal with. Start this tutorial with the nodes shown on screen already entered into your drawing area, where A, B, C, and D are fixed species. Set the concentration of A to be 0.5 units. Set the concentration of B to be 3 units. Set the concentration of X to be 3 units, and the concentration of Y to be 3 units. Next, add a uni-uni reaction between A and X, and between X and C. Then, create a bi-bi reaction between X and B, and Y and C. And finally, add a bi-uni reaction between Y and X, ending at X. Select the mouse clicker button, click on the reaction between X and Y, and move it until you can see all the reaction arrows. The next step is to change two stoichiometries. Select the second reaction where X is autocatalytically transformed and bring up the reaction properties panel. Locate the stoichiometry settings and adjust the first X stoichiometry to be 2 and the second X stoichiometry to be 3. To change the rate law, click on the free format and change the reaction so that it says J3K times X times X times Y. Then, change the rate constant so that it equals 1. Next, we will go one by one through each of the different reactions and set their rate constants to 1. We will also make sure that their rate laws are correct. Now, bring up the time course simulation panel and the graphing panel. Then, set the time end to 100 units and carry out a simulation. You should get the graph that appears on screen now. We are now going to investigate how the different rate constants affect the dynamics of this model. At the lower end of the time course panel, you should see two buttons, one marked Define and the other marked Display. Click on the Define button, and you'll be presented with a window that permits you to attach slider controls to parameters in the model. To select a parameter, click on the parameter and click the Add button. Do this for each parameter until the Define slider window looks like the display shown on screen. Then, click the Close button. To display the sliders, click on the button marked Display to bring up the slider window. You may dock this onto the time course panel for easier viewing. You will now find that by gently moving the sliders, the simulation curves will change. This concludes the final JDesigner tutorial. By now, you should have a good idea of how to use JDesigner, as well as some basic knowledge about common biological models.